Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 115th of physics, and in today's lecture we are going to discuss one of the most basic and important laws of electricity, and that is Ohm's law. Ohm's law is giving us an opportunity to relate electric current and potential difference. The current flows through most conductor is directly proportional to the voltage applied to it. So we can write that V is directly proportional to I. As much we are giving the voltage, that much current will flow faster in the conductor. If the voltage is, which is the potential difference, which is the power given to the electron to move in a conductor, if it is less, then less current will flow through the conductor. So if we are writing it in its original form, then we have to keep the resistance constant, and that is the constant of proportionality. uh, the German physicist George Simon Ohm was the first to verify Ohm's law experimentally. Let's explain it. One of the most basic and important laws of electric circuit is Ohm law. Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it, provided all physical conditions and temperatures remain constant. That is very important, that if you want to apply the Ohm's law, then you have to keep the temperatures constant. If temperature at the same time is increasing, as we are increasing the potential difference, then this law will not be applicable. Mathematically, this current voltage relationship is written as written in the green. V is equal to IR. In this equation, the constant of proportionality or is called resistance and has units of ohms with the symbol ohm. You are familiar quite with this symbol. The same formula can be rewritten in order to calculate the current and resistance respectively as follows. I is equal to V divided by R can also be obtained from V is equal to IR, or R is equal to V divided by I is also attainable from the famous Ohm's law. Ladies and gentlemen, if two variables values are given, the third one can be found. I will tell you a very important rule to memorize all these things in the later part of this lecture. Ohm's law only hold true if the provided temperature and the other physical factors remains constant. In certain components, increasing the current raises the temperature. Yes, this is the practical observation. An example of this is the filament of light bulb, in which the temperature rises as the current is increased. Have you ever experienced it? When there is a filament bulb and you touch it, after turning it on, it will feel hot. So it means the temperature is increased because there is a high resistance in the filament. In this case, Ohm's law cannot be applied. The light bulb filament violates Ohm's law. So remember that Ohm's law is not applicable in all situations. Now let us state the Ohm's law. Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it. But one more thing, provided all physical conditions and temperature remain constant. The mathematical form of Ohm's law is given as V is equal to IR, where V is the voltage across the conductor, I is the current flowing through the conductor, and R is the resistance provided the conductor to the flow of current. Let us understand this law with the help of an example, and we will see that what is the relation between voltage, current and resistance. Ladies and gentlemen, on the left side in the column, cells are given, dry cells. Each cell is of the value of 1.5 volt, and there are bulbs attached to it. So you can see in the first column 3 volt, the second row is 6 volt, and the third row is 9 volts. But in case of resistance, the resistance is constant, not changing. For 3 volt, 6 ohm resistance, for 6 volt, 6 ohm resistance, and for 9 volt, 9 ohm resistance is there. You can see the value that it is increasing when the resistance is constant and the voltage or potential difference is increasing. Then you can see in the last column, in the first case, there is 0.5 ampere, that is double. In the second row, and that is 1 ampere, and that is again increased by 1.5 ampere. But if you observe the row number 3rd and row number 4th, in which the voltages are the same 3 volt, but in this case the uh, resistance is increased 12 ohm. Similarly, 6 volt, the second row, and the fifth row, that is 6 volt. The resistance in this case is constant. So you can see that if the voltage is the same but the resistance is double, then the current is halved. You can see that in the first row there is 0.5 ampere of current. But in the fifth row, the voltage is the same, but the resistance is larger, so it is half, and that is 0.5. Similarly, you can see in the 9. Now, 0.5 half is 0.25, and the half of 1 is 0.5, and the half of 1.5 is 0.75 ampere. So if the voltage is remaining the same but the resistances are doubled, then the current flow will be less, and that is what the Ohm law is telling us. Let us understand this law with another practical daily example. And in this way, Ohm's law describes the current flow through a resistance when different electric potentials, which is called voltage, also are applied at each end of the resistance. Since we can see electrons, the water pipe analogy helps us understand we cannot see the electrons. So this water pipe analogy will help us to understand the electric circuit better. Water flowing through pipes is a good mechanical system that is analogous to an electrical circuit. You can see here the voltage is analogous to water. More water, the water pressure, more pressure on the water, more water will flow. The current is the amount of water, so you have to consider the current is the amount of water, and the resistance is the size of the pipe. More water will flow through the pipe, that is analogous to the current, when more pressure is applied, and that is voltage. And the bigger the pipe, lower the resistance. If this pipe is bigger one, there will be a less resistance toward the flow of water. But in this case, if the pipe is not larger, then there will be a greater resistance to the flow of water, and in this case, less water will flow through, which is analogous to the current. Now here, if we are applying the pressure, more water will flow through, as you can see in this case. But if there is a less pressure, then it means that less water will flow through these pipes. Pressure is analogous to the voltage, and water is analogous to the electrons flowing. So in this way we can understand the analogy of water pipe to the Ohm's law in better way. I told you that I will tell you a way to memorize these, that if we want to find this voltage, we will cover it and I multiplied by, because there is a multiply symbol. So in this case we will see that V is equal to IR. If we have to find I, then we have to cover this with our hand, and then we will see that V divide by R. There is a divide symbol. If we want to find R, so we will be able to find V divide by, if we want to find R, then V divide by I will be. So you have to remember that magic triangle, and as a result you will be able to find the equation, different equation we can create from Ohm's law. So that was another. Now let us do another work example on this, which is given to us the voltage, a potential difference of 240. I have written that for you in advance, applied across the heating coil of an electric kettle drives a current of 8 ampere. So 8 ampere is also written in the first part. A, they saying find the resistance, so we can find the resistance R is equal to V divided by I. Putting simply the values, we will find 30 ohm. In the second case, they say the new current flowing through the coil if the potential difference is changed to 220 volts. So I have written 220 volt. The resistance is the same. Now we have to find the current in the new current if the voltage is changed from 240 to 220. So as I is equal to V divided by R, and that is equal to 220 divided by 30, and putting the values inside this we will get 7.33 ampere. Tomorrow we will clear more of the concept about the Ohm's law. There are many more things, so stick to this channel. Don't go anywhere. Thank you for your time. Allah Hafiz.